Okay, so let's get started. Yesterday was mostly Dimitri. Originally, I thought Dimitri was going to do a 5 minutes, and then it was so good, so he basically did the whole hour, which was really, really good. So I think that's just to make some of you braver to go and do your own thing, but also to see if if whatever we've been doing so far is actually helping students do their own research. And I think that was good. The second half, we mostly just chatted. This is mainly for those who missed yesterday. We chatted and made some plans about what we're going to cover for the rest of the course. And on that front, today we'll do Spark streaming, and then we will get into hopefully scalable geospatial computing on trajectories and over the maps over time for next week. And then you guys are supposed to go and think about your projects more. We can be in touch. And when we come back, I'm going to do a few more key things like recommender systems, some natural language processing, make sure you can process XML files, and what else were we? Deep learning, I don't know, bunch of stuff. Okay, we'll play it by ear, so you can still tell me if you want to do something. So the main idea is to reverse engineer the skills you need for the projects you have in mind. So the sooner you tell me, the faster I can adapt the syllabus. Okay, so today let's, so you have to go and download the latest SDS 2.2 and dump it in your directory. Okay. So you should have this directory here. Okay, and it's updated now, so it has 27 notebooks, and there are two kind of biggish notebooks, O25A and O25B. We will sort of use them to get into Twitter collector, and then we'll, you can come back and understand what's in these notebooks. Okay. And the other thing, if someone wants to actually follow from 26 onwards, then you need to get your own Twitter credentials. I think I made an announcement in the meetup. Has anyone seen this announcement? Or
yeah?
Okay, so that's going to be a legal problem. I cannot share. I don't want to share my own Twitter credentials. So you have to make your own, and that's straightforward if you have a Twitter account. Okay, so we can even do that briefly. So I have put my Twitter accounts in this directory called secrets. It's just a tiny stub, and I'm just doing a lazy evaluation, so it shouldn't show up on the notebook, but it'll work. And you can do the same. Okay. So let's start here. Okay, so Spark streaming is slightly legacy, but I think quite a lot of code is still written in it, and it allows you a lot more control at the level of RDDs. So I would like to come back to something called structured streaming, which is a more recent thing in the last few months. So structured streaming is essentially, to Spark streaming is the same as data frames and data sets are to RDDs, okay? So just as in our philosophy here, we want to try and get you guys close to the heat, and then we'll come back out on structured streaming later. Okay, so it's an extension of the core Spark API that enables scalable, high-throughput, fault-tolerant stream processing of live data streams. Okay? So if you check out these Databricks guides, you can get quite a bit more information, and this should be current. So this is just okay, some examples here. And then structured streaming is we'll probably get to this, especially if we cover deep learning, then we can do this James Bond car detection. That's in the structured streaming context, right? So for Lee, that's one of these videos in the first notebook on Spark Summit that just happened. Okay, and of course, here's your programming guides. So this is sort of our primary resource, the latest structured streaming programming guide. So there's quite a lot here, so we can revisit, but I'm going to take a more practical approach and try to show you guys, and the same with structured streaming. There's quite a lot. And we will be able to combine, if you went through the programming guide for graph frames, and we can start combining graph frames on structured streaming and start doing stateful computations on things as well. So all of this learned so far will tie together. Okay, here's an overview. So Spark Streaming is an extension of Core Spark, and you can ingest data from many sources. So there is a whole ecosystem around Hadoop, the distributed file system, that Spark is actually speeding up by putting things in memory, distributed memory. So Kafka, for example, is a Apache project as well. So here's Kafka. So, okay, it's a distributed streaming platform. It's used for ingesting data, and you can have Kafka queues, being your sources into Spark Streaming, for example. There's other things like Flume and Twitter streaming. In fact, we will write our own Twitter streaming things, which is built around Twitter 4J. So we'll Scalarify it and use it in a couple of notebooks. There is Amazon Kinesis, which is Amazon's proprietary ingestion, distributed ingestion thing. Google, so I was in Google Cloud Summit, yes, what was it, last Tuesday? Yeah, that was really, oh no, that was just the day before yesterday, sorry, in Stockholm. It was really good. So they have their own proprietary things, right? They call something like PubSub, for example. So all these things can be plugged in, so you don't have to, because, in a sort of real context, you may be consulting for someone or and those guys may actually just serve you, things from these sources, and you have to take that, ingest it, process it, and then provide some other output, right? So it's all interchangeable in that sense. Okay, so once we get structured streaming going, then we can use all our standard transformations and actions on RDDs. Okay, so of course you can combine this with machine learning or graph processing, and then send some output back. So this is the big picture. So you have the various input sources, and then you can do streaming and some processing, and then you can, the sink can be Hadoop distributed file system or some other database or some kind of live dashboard that's showing you what's going on, for example. Okay. So internally, it works like this. So Spark Streaming receives live input data streams, and it just divides data into batches. So it's basically micro batching is the architecture, right? And which then is processed by the Spark engine. So this could be ML or whatever you want. And then it generates the final stream of results in batches again. So each little batch, micro batch, is actually a discrete RDD. So that's the abstraction. Spark Streaming provides a high-level abstraction called discretized streams, or D streams, which represent a continuous stream of data, and we will see an example of this very soon. Okay. So D streams can be created either from input data sources, or they can also be, you can also create your own D streams, from simulations, for example. Okay, so let's just quickly look at three quick examples. So I think these, so I may have to come back to these notebooks because yesterday I was planning to do quite a lot. So we'll probably come back next week to cover some of these other things like Twitter hashtag counting, and but we'll focus mainly on Twitter collector here, okay, and how to customize your own experiment to collect what you want from public Twitter streams. Okay, so to understand this concretely, we'll do this first example called streaming word count. Okay, so it's kind of the hello world of Spark streaming. So here's the idea. So what we want to do is set up some configurations to control your streaming app. So so this one, stop active context, essentially is a configuration to control the flow of the application. If you set this to true, then you stop if any existing streaming context is running, because you don't want to be, you can only run one streaming context in one of your community editions. Okay, and then batch interval seconds. This controls the sort of the starting window when you start chopping your discrete RDDs. Okay, and this is actually just a control for the simulator we're going to write. We're going to create a stream that will produce 1,000 events per second. We're just going to simulate like a monkey typing some numbers, basically. Okay, it's from a dummy source. And then this is just some checking that we're at least version 1.4 or above. Okay. So let's do some imports here. So we won't, well, just start importing some storage and some streaming, Spark streaming. Now, conceptually, you can think like this. Discretized stream or D-streams is essentially something like this, where you have micro batches of RDDs at time 1, time 2, time 3, and so on. Okay, and these are basically a tuple, an RDD in some slice of time. Okay. So if we sort of play this little function, it's going to so you don't have to understand how we're creating this dummy source. It's essentially something that's emitting strings. So if you really pay attention here, I'm just emitting, I'm a dummy source plus some random next int between 0 and 9, okay, inclusive. So, so you don't need to really understand this function. It's just going to spit numbers at us from this dummy source. So then what we want to do is take these, so we will have stuff like this coming at us. I'm a dummy source 2, I'm a dummy source 8, I'm a dummy source 0. So these numbers will just change at random. 1,000 of those lines per second is what we're going to be pumping out. So then we can just, because these little RDDs now, the discretized RDD chunks are just RDDs, you can do standard RDD operations directly on them. Right? So we can do transformations and actions. So for example, we can flat map and count the words like we did, right? Just so I can just count the number of words from all the lines that were emitted from time 0 to time 1. So in this case, it's from the beginning to the first second, first second to the second second, and so on, because our slide was 1 second. So that's all we're going to do. So we have word counts. So of course, to do this, we just use reduce by key and simple count. So here is the basic steps. So we first write this function, creating func. So this essentially will return this streaming context. And in here, what's going on? Right. So we first are going to create a streaming context using SSC, right? So this takes your available Spark context in Databricks, and it needs time units. So this is in units of seconds. I'm going to use my batch interval seconds, right? So batch interval seconds was 1, right? We declared it earlier. So now we have our Spark streaming context, which is our starting point, main entry point into streaming. Then we're going to create a stream that generates 1,000 lines per second. So this is this black box thing I didn't explain in detail, this dummy source, which is this function above, and it just creates these lines and a dummy source with random integers. Okay, so that's our receiver stream. So every Spark streaming context will have a receiver stream. Okay, so now I'm going to do my flat map, right? So I take my stream, which is going to be stuff coming at me, 1,000 lines roughly per second. And then I'm going to make this new immutable called word stream, and all I'm doing is flat mapping whatever comes in, splitting by white space. Okay, so now, and then I can just do my standard thing where I take each word in my word stream and I make a word count stream, which is just word maps to word comma 1 tuples, and then I do reduce by key. Okay, just counting. So then I create my temp table at every batch interval. So what I want to do is like create like a dashboard. So I'm going to have a live temp table that gets updated from the word count. Okay, so this is a very nice example of the full process, basically. So what I'm doing is for each RDD, because each RDD is just the discrete RDDs that are coming at me, I'm going to take the RDD and convert it to a data frame first, okay? And then I'm going to name my columns word and count, because that's what's coming out of my word count stream. And then I'm going to just create or replace temp view, this table underneath on high, which is a batch word count table, just creating it. Okay, so that table gets updated every second. Oh, by the way, Spark streaming is not real-time streaming. So I think the latency is in the order of seconds, like fraction of a second, like half a second or whatever. So there are real-time streaming things like Apache Storm that I think Twitter had a big role in developing. That's a different framework. And there's frameworks like that for financial trading as well, where you may need millisecond level decisions. Okay, but Spark streaming is not quite real-time streaming. It's called micro batching. Anyway, so now I have my and then all I'm doing is just printing. So this is printing the number of events so far by simply counting the RDD. And I'm also just creating a string to print out. Okay. And this ssc.remember -1 is to make sure data is not deleted by the time we query it interactively, because we're going to look at this table that's being updated. So, okay, so let's try this. So start streaming job. Stop existing streaming job, if any, and start and restart the new one, because we do want to make sure that there are no, streaming jobs that are already running. So then we want to get rid of them and then start our new one. So to do that, we just take streaming context and get active or create, and into that method we just pump in the stuff we made, creating func. Okay, creating func is what we just made up here. Okay. So it's easy peasy, right? So that's all we have to do. And and then once you've done this, you have to start the job, and then and then have some criteria for stopping it. Okay, so here it goes. I'm a dummy source 0, I'm a dummy source 9, blah blah blah. Okay. Now here's interactive querying, because there's that table, right? So you can see 0 is 82 times, 1 is 87 times, and so on. And the word source is 893, dummy is 893. So there's some lags, I guess. So if I rerun it now for the current table, you see you get different numbers. 0 is 92 times as opposed to 82 times, and so on. So that's like a baby example of dummy source, streaming, transformations, actions, updating a live table, and okay. So now if you go to the Spark UI, so if you hit, say, clusters, you'll go to here. So you can see in your cluster, you go to Spark user interface.
I have a question. So this the SQL table is for one of these batches.
Yes.
So within each batch,
Yes.
how many counts?
Yes. Yes.
Okay.
Yeah. Okay. There's some delays and things like this, so you're not. Yeah. You're not
right,
seeing
because
exactly.
the sleep isn't random, so it's the delay in system which causes
yeah,
work.
Yeah. 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 So there's some. Yeah.
Scheduling.
Yeah. So if you hit the streaming button, then you will see, like stream, it says last 88 batches, 0 active 88 completed, and number of records per second, and so on. Okay. So that's my stream. So it's still running. So I can go, this is kind of important. So you want to, maybe stop it now. Okay, so you can just hit this. This is just, it basically uses this get active method, get all the active streams that are running. And in this case, there'll be only one. Because, to run multiple streams, you have to set up a different architecture for the clusters. And then for each, I just basically stop it. Okay. So how did we do that? Yeah, so something like 27 minutes, right? That's good. That's enough. Let's just get really deep dive into Twitter right now. I mean, you can get back into details later, right? So before I take you into Twitter, I'm going to. So there used to be something called Twitter utils last year, but for some reason I can't import that library. So anyway, we have this other little package, extended Twitter utils, that we wrote for this other project. So we'll just call it. You can actually abstract it for the next notebook, but we need to do a couple things, especially in the community edition. You need to install a couple libraries. So if you go here, so you need Twitter4j, which is Twitter's Java library. And then we also need, because that's how you can do your authentications and go into the public Twitter streams in Java with Scala, wrapped into Scala. And then we also need another one for this next notebook, which is Google's Json, Google's JSON called GSON. So if we look here, again, if I hit streaming, because I stopped it, there should be no streaming job running now in the UI. Okay. All right. So now let's hit libraries here. So of course, lots of libraries. This is the academic shard. So it's lots of people from. Oh, there's someone from Australia. So the libraries we need are just this one, Twitter4j examples 4.0.6 is working fine. So please note this, Twitter4j examples. So you need to import that from Maven, right? Everyone knows how to do this in the community edition, right?
I forgot.
Okay, no problem. So let's do that. So we go here, log in. So it's gonna do the steps mechanically. So I go here. So so the first thing I need to do is delete this guy. Right, and then I want to import yeah, so I guess maybe I should do this in the proper way, right? So you can go here, if you're just anywhere in the world, you can go to 2.2 and go to the GitHub repo, because I'm just putting what is it called? GitHub IO. I'm just using some markdown to pump via Jekyll, the website. So the actual stuff is just here. So then if you go to DBC archives, so 31 minutes ago, I pushed something into 2017, and then you can just, how does this work? I think I can just copy the URL. Maybe. So I think, will that work?
Yeah.
Okay, good. So I forget all the time. So yeah, let's try this. Okay, good. So yeah, that looks, so this is the DBC, is the Databricks archive format. So that should bring all that stuff in here, and then, okay, so let's make sure that, yeah, all the notebooks to 27 are here. So then what I need to do is go to shared and streaming. Oh yeah, so I already have some stuff. So let's just import and then, ooh, sorry, make a library, I think. What is it called? Create library. And then let's see, so if I go here, so I think if I know the exact details, it'll be easier, but let me just do a JSON. Oh, probably should go here, search. So yeah, it's Maven Central. Spark packages are just for Spark, right? So let's see, I hope this will find it. Okay, good. So Google's JSON is this one, JSON 2.8. I don't remember what I used in the other one, but it should just work, I think. So I select that, and then I create the library. And I can automatically attach to all clusters. Okay. So now, yeah, so this is 2.7, so I don't know if there's multiple versions. Okay, so I untick this, or indeed automatically unticks, which is good. And then what else do I need? I need Twitter. So yeah, this is PyPy, but so let's go back and play the same game. Create library.
Json was Maven, or?
Yeah, Json is made, yeah, Maven, because it's quite generic, right? Yeah, this should also be search. So yeah, so it defaults to here, so you have to just turn this here, and then Twitter for Java. And there's a lot here, but I think this examples one is this super bundle thing. It has all the other things you need, I think. Okay, so let's create the library. See, it has all these other jars, right? It has Twitter 4J core, async, examples, media support, and stream.
And for Json was 2.7?
I think it doesn't matter. Yeah, 2.7 is what I had. Let's be brave and put the latest, and if it messes up, we'll make it better.
So, did you include after Json? What did you include then?
The Twitter 4J.
Could you show it one more time? So
Yeah,
the
sure.
Maven is slow to search.
Yeah, I know, because we're all searching in Oregon probably now. So let's see. So okay, so I mean, you can actually do this Twitter 4J examples. No, maybe not. You need to do a bit more. So yeah, so I guess I'll delete this and redo this. So let's go to shared and import. Sorry. Create library. Create library. And then yeah, so. Yeah, so I just choose Maven coordinate in the source, and if you know the exact thing, you can just type in. But I this is a safe way to look for everything. And then I type Twitter for J, and then it just
Which one?
then the examples. This one.
Okay.
So I think everyone here. Okay, so then I hit create library, and then I see all the jars. Yeah. Make sure stream is there and core is there and attach automatically. It's good. Okay, so this should just do it. So to be double sure, let me go to here, and yes, you can go to notebook 26, for example. Then what do we have to do? Start a cluster, right? So create cluster. How do you spell Sauron?
There.
Sauron?
Or M?
You know what I'm talking about? Sauron, yes, is good. So let's see. Sauron from Atlantis. So, okay, so I don't know. I don't think 2.2 is okay for this US West Coast. So create a cluster. So when this guy comes up, those libraries will automatically attach. And right. So in the meantime, those who have Twitter accounts can go here. Let's see. Right. I need to edit out that part of the YouTube. Oops. Okay. So what you need to do is actually the instructions are here. So let's go back. So I'm going to go back to this edition for now. Okay. So 025A has this extended Twitter utils thing. So don't execute this. We'll call it from the other notebook, and it just has some little extensions of the Java code, so we can write our own stream Twitter collectors from it. So we will understand this more and more, and I'm hoping to expand on it as we progress for geospatial queries and things like this. So you don't have to really get into this now. And this one is just for transformations and actions. So once we get the raw tweets, we will turn it into JSON files. And I will do a boilerplate code quite soon, right before Fika. And then we'll come back and make into a nice function. And then once we have this nice discrete streams of JSON tweets, this is JavaScript object notation stuff, then we will apply some nice, turn them into nice data frames for us to play with. So that's what this thing does. It's like several months of me and a couple students reading Twitter developer APIs, what it actually means, all this content, because Twitter's schema evolves, right? What's in each tweet evolves over time. So we'll come back to that. So let's sort of get in here, right? So this is our main thing we want to do. We want to collect tweets. And unlike Facebook, Twitter has a nice model, and anyone can collect from Twitter. Anyone can collect for free 1% of all tweets in the world, which is what we'll do today. But if you pay a little bit, you can collect 10%, which is called a DECA host, the Twitter Fire host, spitting out what are called status updates for the whole planet, right? So and then you can get 100% of it legally, buy it, and you can do whatever you want with it as long as you don't violate Twitter rules, Twitter developer rules. And if you read all of that, and every single word, at least a couple months ago, it takes you right into UN human rights violations and jurisdictions on the local laws of the land. So how you operate with Twitter in Saudi Arabia is very different from how you would operate in Sweden. So there's a lot of legal issues. So you're grown up, so you can read it. So you can do a lot with it. And specifically, you're prohibited explicitly from using geospatial information over extended periods of time of the same users. And, you know, okay, there are limits to what you should supposedly do with it. We'll come back to that concretely. So what I'm going to do is these are the main steps. So let's collect from the public Twitter stream and write to the distributed file system as JSON strings. And I'll do this sort of in a boilerplate way. Okay. So we understand the concepts, and then we'll turn this collector into a nice function. So we abstract and modularize it off. And then finally, I'll use some data frame-based pipelines in the other 025_b notebook, TTD tweet transmission tree function notebook. We'll again abstract that for now, and we can descend into that later. Okay, so we can do transformations and actions quite quickly and start using Spark SQL. So we already did this. Let's see. So just to be really sure, let me go back to Community Edition and Twitter Collector and attach it to Sauronoi from Atlantis. And let's just Control-Enter. It should be fine. Has anyone run into trouble running this?
Command 36 doesn't work.
Okay, what about command 4? Whatever this.
Yeah, it worked.
Okay, so it's taking a while. Okay, well, yeah. So anyway, this is loaded up this extended Spark streaming utils. I think it'll work. I'm going to just go back here. Okay. Okay, so I'll just stay here. See. So then what this one essentially does is just take Twitter 4J and set up a Twitter receiver stream for us, and so we can kind of think of this as this dummy source example, some abstraction, and then start directly playing with it. Right. So yeah. So I'll go here because my credentials are here. So if there is a streaming job running already, it's just a safe practice to just stop it. But be careful, especially in the academic shard, because if somebody else is running a streaming job, I can kill it. I mean, okay, but you guys don't have to worry about it. So then here is I'm going to just create a directory where I'm going to store stuff. And this directory can kind of get filled up really quickly because there's about 30 to 60 to 90 tweets per minute in the global 1% free public streams. So because we are limited by the directory sizes in the community edition, so I'll try to sort of get into good practice. So I have this output directory root. I'm just calling it datasets tweet stream temp. And I'm going to remove it, just to make sure it's clean. Okay, so it's so then I'm sort of setting up the slide interval. This is what controls the size of your discrete streams. So this is duration is 1,000. So duration is in units of milliseconds. So it's 1,000 milliseconds is 1 second. So again, recall this is basically what we're going to do. These streams, RDDs at time 1, time 2, and so on. These are intervals of 1 second now. And now we're going to import Google's JSON library. So our goal is to basically take each RDD in the Twitter stream and write it as a JSON file in our DBFS, right? So I'm going to create my Spark streaming context. Remember, it's the entry point in Spark streaming. So I take my Spark context and a slide interval, and I can create my SSE Spark streaming context. Okay, so here's the stuff I was warning earlier. So caution, extracting knowledge from tweets is actually fairly easy. using techniques shown here, but one has to take legal responsibility for the use of this knowledge and conform to the rules and policies linked below. So don't say if you get stopped at some immigration, Russ taught me how to do this. I have no idea who you are. So, okay, so, Twitter rules, right? It's, this is just Twitter rules as a Twitter user. So that's just, but the rules you want to really pay attention to is the Twitter developer and policy Twitter developer agreement, right? So there's quite a lot here. So compliance with laws, there's like local law clauses and so on and so forth, right? Doing this collection in Singapore will be very different from Israel or Saudi Arabia or India. And things are changing quite fast as well. So for example, I already pointed out, different countries have their own sovereign laws, their own national laws enforceable in interesting ways now, because if say someone is mining Twitter in a way to maybe recruit people for their cause, which could be terrorist, state or non-state terrorism, whatever you want, or like some kind of marketing, like getting people hooked on something, and if they mine it in a way that's bad, or fake news, like getting clickbait, that's not really allowed, and say this person is actually somewhere else, maybe I don't know, Estonia or who knows where, Sri Lanka, but they're using the AWS servers, the public cloud that you can pay and for use, but that AWS server, say, is actually in Stockholm, right? There's supposed to be ones built quite soon. Then the Swedish government or intelligence, whatever, the Swedish state has the right to enforce Swedish laws on the operator wherever they are in the world if they are using the cloud infrastructure on Swedish soil operating with Swedish electricity, right? So this is I don't know if you can manipulate Swedes by working with servers from Deutschland. I have no idea what this all means, but I'm just telling you, there's a lot of legal issues that are still unclear. Okay, so I also want to, so once you go to Twitter APIs, oh man, we're so out of time. So I'm going to open incognito. So this is where you want to go, apps.twitter.com. And then if you sign in as yourself, you will basically get to a little tab, and you can just create an app, put some URL, you just take the default settings, and you will get these 4 strings: consumer key, consumer secret, access token secret. These are the 4 strings you want to keep. So it just allows your application programming interface to be authenticated. So then you can do everything I'm doing by yourself. Okay, so we will just new tab. So I guess we should see if we can stop at this point. But what I want to point out is in this course, we are supposed to be aware of ethics and laws. It's very, very important in data science, especially if you want to do something product, something commercial. So, so what is the real problem with social media mining, right? There are other issues, beyond just illegal things. So even if you're not violating the Twitter developer agreements or some sovereign laws where your clusters are operating from, but you can have other sort of subtle things that most people miss. Okay, so so there is laws against hate speech, for example, laws against recruitment for terrorist purposes, for example. There is laws against incitement to genocide. So this is just on the sort of security war front, right? But now if you start looking into other things like, more, it's called computational propaganda, right? There's a whole burgeoning field now. So you can actually, in fact, buy services of companies that actually specialize in computational propaganda, right? And so you can read a lot about it here. you know, fake news like election monitoring. You can, have these part human, part bots in Twitter or other social media platforms that you can use to, manipulate people. And there's a lot of, I'm not blabbering, right? This is really nice working papers from the Oxford Internet Institute that was published a couple months ago, providing a lot of deep field research, like what's called deep hangout in anthropology, where people are hanging out with various, groups in the US, and there's reports on various European countries as well. So anyway, read about things. There's also this other thing you need to be aware of. This is not just Twitter. Essentially, content is commodity. So there's a whole market for this. So in fact, there was this really awesome book I recommend if you're bored. David, I guess, Data and Goliath. I mean, this is a brilliant book by Schneider. He's, a really bright guy. So I worked on recommender systems as well a couple of years ago. I mean, actually 3 or 4 years ago. You can just go to the market and buy like information on people. Something about ever cookies. It's not scary, but there is actually a market for it because people want to sell something to you. So they want to, And even 4 years ago, my students were improving recommender systems by not just the individual, but the individual's behavior in certain locations at certain times. So the right thing to pop up to the same individual, right? This is, and you can make a lot of money because every click, and this is targeted advertisements. So that has this other side as well, because now you can potentially be exploiting and violating some law. For example, in Europe, there is a law called right to be forgotten. So some of the tweet fields I've seen recently have extra tags that tell you something about this user's requesting some right to be forgotten thing. I don't know exactly. I haven't descended into it. So, okay. But even simple things, forget about this is, even like without the personal human thing, there can be other crazy things that can happen with machine learning, right? So I mentioned yesterday briefly on this whole predictive analytics, where there was a big industry. In fact, I was part of this industry for a while, where you're trying to do predictive policing. You're trying to sell some algorithms, some decision actions to the police department. And that actually it was shown recently to actually cause a lot of problems, actually making things. So anyway, there are lots and lots of links here. I try to keep this up just because I want to remember what I read, but this is not a library, right? But it's got quite a lot of stuff. And I like this, there's a little video I had, maybe I removed it. Anyway, it doesn't matter. So you know something about ethics now. Be careful. In machine learning algorithms in this, let me just tell you one more thing. So this book, Weapons of Math Destructions. This is a really, really great book. And here there are instances from big companies, including Google, where they made like, what do you call cultural or cultural bugs in the way they chose the training data. Cultural meaning human prejudices. All of us have prejudices or bias, right? But these things can trickle into the algorithms in unforeseen ways. Right? So and then they have to kind of actively go and fight all this. But anyway, maybe we should take a break, I guess, and come back to this. So I basically entered my secret Twitter credentials in a notebook, and I'm just in this other directory called secrets, which you don't have. So if you went and got your 4 keys, you will get these 4 strings. You can just fill them out, uncomment this block of code, and fill your own stuff here. Then you will be ready to go with me. So if you want, you can do that while we have fika, and then I'll continue with that. Okay. Sounds good.
Okay.